In this particular program, what I am demonstrating is over here we are making use of decision tree, and that to be implemented within the R language. So let's go through the program line by line. So at first what I'm doing is that I'm giving a call to rm. This is a function which would clear the environment variable. Well, although there is no value in the environment variable, if had that been so, it would have cleared it. So let me run the code. So that's it. Now over here I have to implement three different packages. The CA tool is used for the splitting of the your data set into training and testing. For that you need this one. rpart is used for the decision tree, and rpart.plot is used to graphically represent your decision tree. Okay, so let's add this library one by one. So train state got added, CA tools, rpart got added, and rpart.plot actually got added. Well, these packages are actually right over here. So if I scroll down over here, you will be able to see that CA tools, let me go graphically. Yeah, see, because I added the library over here, that's the reason you can see the checkbox is enabled over here. The same goes for rpart and rpart.plot. Okay, so these packages are important, then only it will be working. Now let's come to the dataset part. Here is the dataset. I have got one CSV file over here, so let me run that and see the environment variable. The variables now is active. So over here what he's saying is, like, I have got 25 rows over here, and it is distributed among two columns. So two variable means two columns over here. We can see this by the function called view dataset. Let me click over here. As you can see, I have got two different columns over here. One is called age, the other one is called by book. The age column, or this particular attribute, is actually the independent variable, and this is my dependent variable. So based on the age, it will be decided whether the person is going to buy a book or not. So that's the analysis which we are going to do it. Okay, so that's what the two variables stands for actually. So this is one variable, this is another variable. Now over here what I have to do is that, as you can see, my independent variable is having a numeric value, whereas my dependent variable is actually having a categorical value. There is a string value, yes, no, yes, no. So I need to replace the string value into numeric form. That's how machine learning will actually implement. So for that reason, what I have to do is that I have to give a call to a special function called factor, which will actually convert the entire thing into 0 and 1, and then the whole thing will be converted into a numeric form. And for that reason we are giving a call to the factor function over here. So right now, as you can see over here, this data in the form of a string, and I need to convert it into the numeric form, and for that reason we are giving a call to the factor function. So let me execute this line, and the factor got executed, and let's see the data set what actually required. So as you can see over here, the initial string data got converted into numeric form, because this is what actually I need for machine learning to actually learn the concepts. Keep it in mind, you cannot keep the string data over here. It all has to be transformed into the numeric form. Then only your ML actually can be implemented over here, or data science can work on it. So now what we have to do is that this is the total data set which I have got 28 rows are there, and I need to split this into two segments for training and testing. And for that reason over here I have written sample.split, and this is where the CA tool come in picture. CA tool is actually responsible for giving a call to sample.split, whereby it will split the data set into two different parts. And one more thing, let me tell you, over here in the factor, the column was initially having the value yes, no. So I wanted to replace this in numeric form. So no will be represented by 0, and yes will be represented by 1. So that this is the level which is here in the data set, and this is the label that will be converted into. Okay, that's how the factor actually works. So now sample.split is actually present inside the CA tools, and that is meant to split your data. But before that, you need to mention that which is your dependent variable. So the actual data set is holding the entire matrix, entire data frame, and from there you have to mention this particular attribute or particular feature that is your dependent variable. So as we can see over here, this is my dependent variable. So dollar is working as separator between the actual data set with that of the dependent variable. Okay, and here I've got a split ratio. 0.8 means 80% of the data will be used for the testing part. I'm sorry, 80% data will be used for training part, and 20% data will be using for testing part. We can see that actually. Now the split will take place, but before that we need to figure out one thing, that how it will differentiate that which one will go for the training, which one will go for the testing. And for that reason And for that reason, what I will be doing is that let me run this code, and you will see something very interesting taking place over here. So as I executed this line, a new reference got created, and let's see what is there inside this new reference with the help of the view. Yes, as you can see over here, you are getting the data in the form of true and false. That means that the record which are basically true, they are the one that will be used for the training part, and those which are false will be used for the testing part. That's how the split is going to work actually. Okay, so sample.split is going to not only split the record, but to identify which data set will be used, or which particular record will be used for training and for testing. What it does is it actually for the training part, it will represent those tuples to have in the form of a true, and those will be used for the training, they would be differentiated in the form of a false. So that's how the split is actually going to represent. Now I need to separate, because still the data is a form of in one single reference which is actually having a 28 tuples, but I need to split them, and for that reason we will use the subset. So subset function, where we provide the whole data set, and we also represent over here that which are the data that I need specifically. So that means 80% of the data will be going for the training, and for that reason split the majority of record is in the true, because 80% would go for training. So let's go for the subset, and you will find that now the record will be broken into, see, out of the 20%, 28 records were there. Out of this 80% data, that means 22 record has been taken for training, and the rest 6 record will be used for testing. So let's go and click on the testing, and here it comes. See, the 6 record is used for the testing part. That's how the split actually has taken place. So 20% would go for training, and 6 would be going for testing. Okay, now once we have broken these two data set apart, now what we will go is actually we will implement the our execution, and for that reason we need rpart. So rpart will be used for performing the decision making. So how are you going to perform decision making? And for that reason there are certain parameters which you need to understand. So the first parameter is going to tell you that which one is your dependent variable. Excluding the dependent variable, rest are all independent variables. So that's how the thing has been identified over here. So formula equals to, you need to write down over here the respective feature which is my dependent variable, and excluding that, so there is a tilde sign and there is a period over here. So this is a period, that means that this is my dependent variable, and rest are all independent variables. So that's how the formula has been put forward. Now it will learn, or it will get trained from the following data set. That is a training data set, and the method that we are going to use over here is the classification, because right now we are working on the classification in the form of decision tree of the supervised machine learning algorithm. So method equals to class means over here we are going to use the classification implementation. So that's the reason we have gone for class. So once we execute this piece of code, the classifier, an object you can say so, will get generated. So let me execute this line, and as I does that, as you can see over here, the classifier got generated. So this is what actually will be useful for performing our prediction, because this is the reference that actually had learned from the following training data set that how exactly you will do the prediction. So for that reason now we are giving a call to the predict function. So in the predict function what we are doing is that we are using the same training data set to figure out that how well it has understood. Right now we are not injecting the test data set, we are going to work on the same training data set through which it actually learned. So the predict function will be making use of following for three parameter over here. The first parameter would be your classifier, the actual reference that has been used to learn the model. So that's a classifier which we will be using over here. The next we would be using the data set through which it would do the prediction. Again I'm saying this is the same data set through which it actually learned the entire thing. I'm not using the test data set over here, I'm using the training data set over here once again, just to see that how well it got trained. Okay, so for that reason I'm using the train data set, and here again since we are working on the classification supervised algorithm, so for that reason we have written the class over here. So let's execute the predict function, and as I do that, as you can see over here, the predict y got generated, and since we are working on the training data set, we have got 22 tuples were there. So over here also the factor is 22. Now like how do you figure out that how well it has understood, how well it has prepared itself. So for that reason we are going to use something called confusion matrix. So with the help of a function called table, we would be able to generate the confusion matrix, and through that we can differentiate that what was the initially what was given to the model, and how well it has learned itself. So let's come with the function called table, and over here we are passing again the training data set, because we have been providing the prediction was based on the training data set, and here we have mentioned that which particular column is my dependent variable. Here the column has been provided, and this is the one that is been like the model which has generated that model, that reference we're passing over here. So one way to say that this is the actual data set, okay, where the model learned from it, and this is the data set that has been predicted by the model. So that what we are passing it into the function called table, and we are expecting from there to generate the confusion matrix. So through the help of confusion matrix we can figure out like what is the final prediction from the system, and let's print the data. So as we do that, here it comes. Now this is something very interesting. This is a form of matrix. So over here 0 0 means it's true negative. That means actually the actual data set has got true negative 8, and the prediction is also 8. That is absolutely correct. But over here if you look at this, that is called false positive. So it is expected to be, this is something which has been wrongly figured out. So 0 over here, see, false positive means actually it is no, but my machine is predicting that it will be yes. So prediction has been yes, but in reality it is actually no. So this is something that is the error. That error got generated over here, and in context to true positive it has been all correctly pointed out. So in reality there were 10 record which was positive, and the prediction has also generated that it is positive. So over here false positive didn't turn up, okay, the false positive was not there. But in case of negative, yes, there has been 4 rows that has been wrongly generated. Okay, so that's how through the help of confusion matrix we can figure out that what is the comparison between the original data set in comparison to that of the one which the model has generated. So that's how the confusion matrix would be working. Now let's provide a new record and see what is the prediction. So over here is my actual model, the classifier, and we are going to provide a age value of 47. So we are trying to understand, we are trying to verify that if the client age is 47, that will that person be willing to buy the record or not. That's what we are trying to assume over here. Okay, so what we are doing over here, we are just passing one record whose age is 47. Now since the model works on the two-dimension matrix, that means it works on the row and column, and this is just a single tuple. So for that reason we have to convert into a data frame, and for that reason we are writing data.frame, so that the single dimension will be converted into a multi-dimension, where we have got the age has been column, and age will represent as column, and 47 will be represented as a row value. So that's the reason why we are going for the data.frame for the conversion of a single instance into a two-dimensional matrix. And again we are using the classification decision tree, so for that the type is still class. So this is the new data set which we are feeding into the existing model, just to understand that how well the prediction like the model has trained itself, and let's see what would be the assumption by the model. Okay, so now let's run this piece of code, and it got generated. Yes, predict buyer has been generated. Now here is something very interesting. As we know that this is a decision tree, so decision tree will be represented in the form of 0 and 1. So for that reason we have to convert it into a string format, so that we can print it back. Okay, in case if the buyer is not going to buy the book, then it would be 0, and in case if the buyer is going to buy the book, it will be 1. So for that reason we are converting the numeric value into the string form, and for that reason we are using as character. Okay, so this function is required to convert your numeric data into a string format, so that we can print it back. So let's run this code, and this value will also got generated. Now we can print it, and here it comes. So the machine is predicting that if the customer age is 47, then there is a high probability that the person would buy a book. Okay, that's the assumption that the machine has come up with. And now we can print the entire data set, entire prediction in the form of a graphical representation. So let's run the piece of code over here, and here it comes. Look over here. So in case if the age is it's taken over here 35, but it would be actually 47 nonetheless. So if it is below 47 or below 35, then there is a chance that the client will not buy the book. So that prediction is 36%. But if anything above this, like over here, if it is above 35, then there is a high possibility that the client will buy the book, and the percentage probability is 64%. Chances are there that the that the client is going to buy the book. Okay, that's the prediction it has gone through. So now let's do one thing over here. Let me quit this one, and let's start the session once again. And this time what I will do is that I will give a lower age value, and let's see what happens. But since the session just got started, so I have to run the code one more time. So let me just run it quickly. So the library, yeah, and this is my actual data set. So fine, and this is my conversion of the string data in the numerical form. Everything went fine, and here we went for the training part. This is my separate training data, this is the separate testing data, and here is my model getting trained. Yes, and now we are performing our training data set testing, and the confusion matrix is fine. I don't need to print the confusion matrix. Let's come to the new record over here, and this time I'm going to provide a value, suppose of the age of 20. If the customer is at the age of 20, let's see what the prediction goes. So we're converting the data in the form of string, and now the result is yes. See, it rightly pointed out if the age is 10, because if you see my data set over here, you will find that whoever age is above 40, there's a high chance that the person is going to buy, like 39% is going to buy, but 27 is like 24, 20, 28. See, these people are saying that they will not buy the book. So for that reason, this is a very clear-cut distinction, that if the age is around 20, the chances is very high that the person is not going to buy the book. Let's print it graphically once again, and here it comes. And as you can see, the same thing it's saying, that if the age is below 35, the chances are very high. 36% chances are the person is not going to buy the book, whereas in this case, if the person is above 35, so 64% probability is that the person is going to buy the book. Okay, so that's how we could figure out that using the R programming language, we realize that how to perform the classification implementation in the form of decision tree, where we can predict whether the person is going to do a particular task or not. Okay, so that's all from this portion.